Welcome back, guys, to episode 5 on how to make a multiplayer survival arena game using Unity's Unet system. So in our last video we developed the shooting script, and right now, before we start the grappling hook component and eventually completing our quote-unquote 2-week goal, this is our 2-week goal. So before we get started with the grappling hook, I want to go ahead and go to the test dummy script, and I want to make it so we actually synchronize the health between all clients. So to do this, we're gonna have to say using Unity engine dot networking, because we're going to involve some networking aspects in this. So we're only going to have a variable, and we're going to say int health. Easy. And we have to make this a sync var. A sync var just means we want to sync this variable across all clients. That's all this is doing. And because I don't want it public, we just say it's also a serializable field. Now, once we did this, we can go ahead and go to our take damage method and add in a parameter and say we want to get int the damage from the take damage method, and we want to say the health, our health is going to be minus equal the damage. Easy. So once we do that, we can go ahead and test this. We can take debug.log statement out and go call the network behavior, or else the sync var would not be able to properly implement it. So we can go back to our game and hit save. We have to add in the damage that we had in last time. Just say damage, it filters in this parameter into the take damage method, and it will be 1. But I just realized before we actually build, we're gonna have to actually say how much health the test dummy is gonna have. So to do this, we say int maximum health, and at the start of when it's void start of the game, we go ahead and call a method, and we're going to say set values on start, just to ensure that our values are properly synced up. And we go ahead and say void, copy and paste this, and takes no parameters. We just call a basic method and say health is equal to m health, and we just say this is 100. Easy. Now once we did that, we can actually finally go build. So go ahead and build our scene. So we can go ahead and host it on here, and go here and join with the client. And as you can see here, the cube has 100 health, and if I shoot it now, oh, of course, that I am completely rushing it, because we're going to be using the networking. It needs to be identifiable to the server before we can actually act upon it. So to do this, all we have to do is add a network identity, just like our player prefab has a network identity, because the server needs to be able to keep track of the player and now we also need to keep track of the cube, which in this case is our test dummy. So sorry about that, guys. Now we can go ahead and test, build the client, same as before, open it up, play here, post it on this one, go to client, and go to our here, and we just shoot, and as you can see, we are shooting it on this client. And if we go to this client and he shoots it also, you can see it is also going down on our main client. And once it hits 0, we want it to be dead, but we can't do that now. We'll just go ahead and easily say in the test take damage method, if health is less than or equal to 0, we want to go ahead and destroy this game object. Well, we don't need this actually, we just need to say game object. This is not needed. So once we do that, we have a fully functional server client shooting method. So now we can move on to the grappling method. So once we do that, we can go ahead and create a new C# script and call this one grappling hook, and open that one up. So like any other network script, we want to be again using Unity engine .networking, and again change this from network to network behavior, mono behavior to network behavior, sorry. And now once we have that, we want to get a couple variables, but before that we can just create our methods and we'll create our variables along the way. So like our shooting script, we want to check if we're pressing down a certain key, and as it's been suggested before, you're going to be able to choose what key you want. I'm going to create a input manager in this series, so stay tuned for that. But for now, we're just going to say if our input dot get mouse down. So unlike our shooting script, we want to just check if it is pressed down, so it only checks once. So if it's down, and we want to check the right button, and if you guys are unaware, the left mouse button is 0, the right is 1, and the middle is 2. So if we're pressing down the right mouse button, we want to call a function. So this function is going to be, it's going to have to be a command function, because we want to call this command on, so we have to tell the server that this method is currently running on this client. So to do this, we just say, so cmd like any other command, and we say find grappling point. So go ahead here, void command grappling point, and say this is a command. So all this command is doing is calling another method that is going to be called on this client. So for that, we want to say it's going to be a client RPC void, and for this it needs a RPC prefix, so before any naming. So for this, all it just is start grappling hook. So in this one, calls that function. So it's a function within a function. Its only purpose is to call the function from the server instead of just the client. So all the clients are able to see that you're actually grappling, whereas in their view, you're not actually grappling, you're just moving really fast, so they can't see the grapple. So you have to tell each client that you're grappling currently. So in this method, we want to, just like the shoot script, we want to shoot a ray and we want to hit a point. So to do this, we go if physics, physics.raycast, and instead of having it from the barrel end, we're just going to shoot it from our body. So we'll just be shooting it from prefab. So we're just going to be shooting it from the middle of our body. You can change this however you want. You can have an extra grappling gun or whatever, but right now we're just shooting a raycast from the middle of the thing to wherever we're aiming. So to do that in the script, we go ahead and say transform dot, you know what, I want to shoot it from the head. So instead of shooting it from the body, which it is currently being the script will be placed on, I want to shoot it from the head. So to do that, you just say get child, and just like any index, it starts off with 0. So the first one is always 0, and then it goes 1, 2, 3, 4, 5. So we say get child 0 dot position, transform dot get child 0 dot forward. So basically, just like the shoot script, we're just shooting the forward from whatever our head rotation is. And we want to filter in a distance system because you don't want to have a global grappling hook. You can if you want, it sounds pretty fun, but just to limit it, just to make it balanced, I guess, you just have to have a limit for that. So to do that, we say int, for testing purposes, let's make this public int max grap distance. Easy enough, and we just say that's our maximum distance that we want on that, and we go ahead and close both the brackets, and we want to do something. So if we're pressing it down, we want to shoot the raycast, and if we hit something, we want to check a couple things. So for that, we have to get a boolean. So if we hit something, we want to say we are grappling. So we're in middle of a grappling sequence. So once we do that, we want to say true. So simple boolean, say we're grappling, just so we can identify that we are currently grappling something. We're in mid swing. So now we want to store a couple variables, and we say vector3, and we can go ahead and say, I just realized we're not actually getting a raycast hit information. So to do that, go raycast.hit, and just like our shoot script, and call this one hit, and before we get our max distance, we just say out hit information. So all it's doing is sending this information and storing it here. So in this vector3, we can go ahead and say we call this one the hook point, because that is the point that we hit. So we call that one hook point, and for here we want to say the hook point is equal to the hit dot point. So the hit dot point is just the vector3 global position. So let's say you're standing here and you shoot up to this spot. This right here will be the hit point. This exact spot in the world position is where the vector3 hit point will be, hook point, sorry. So that is what we're storing in there. And we need to have a couple things. So technically that's all we need for this. So I'll get ahead and come back to this later. So we want to check up here. So if let's just take away this. No, let's keep this for now, just in case you guys don't know. So if we are grappling, so if grappling is grappling, we want to call a function. So just like the command function up here, we want to call another command function. Oops. And say grappling, because we want to grapple now. We have the points. Now we want to actually move to that point. So again, command, oops, I'm all over the place today. So, and say void, copy and paste, because don't want to make mistakes, so I'm kind of lazy. So once you did that, just like before, we want to call this on our client. So again, come down here, void RPC grappling, easy. And we have to say this is client, again, client RPC. Call this function from the server. Now we want to go ahead and move our position to where we hit. So to do this, we're going to use the vector3 lerp function. So vector3 lerp takes 1 point and another. So let's say we have variable a, which is variable 1 here, and variable b, and that's 2. So the t function here, it is the interval rate of which you will lerp between this vector3 and this one. So just say this is 3. So let's say this is variable 1 is 1 and this is 5, and for your t value we have 2. So it will skip a interval at 2 and will be here 2. So this, it's just lerping 1 2 3 until you're up to your b variable, sorry. So I got a diagram here of what we'll be doing in game. So we'll be shooting a raycast and we'll be hitting a point, and the formula we're going to be using will be using these two variables. So the vector3 of our current player position will be the variable a, and the hit point that we hit with our raycast will be variable b, and we want to fill in however fast we want to travel. So that's up to you. You can have it really quick or you can have it slow. It's just up to you how fast you want to. So the higher number will be the more intervals it will take. So please tell me in the description below if I screwed something up. I'm not sure how to explain it anymore. So this is just where you need to focus. So stop the video here and just have a look at this little diagram and you can see what we're going to be doing. We go back into our script here and we want to say our current transform position, we want to change it, and we want to say we're going to lerp between our current transform position and the hook point, and we want to up here, we want to, let's say we'll call this one a public int, and we say public int, let's call it speed of travel. You can name it whatever you want, just in case, just so you know this is the speed of what you'll be traveling. And what I like to do here is use the range attribute and just say we want to have the minimum value of 10, or let's call this 20. So just these attributes here, we'll just create a slider in the inspector that we can just easily slide along however we want, and the minimum will be 5, so we'll start on 5, and the maximum will be 20. So we can only, I'll show you in a moment, but so it's just a little slider, and I like to just keep track of it. So here we want to say this interval rate, we want to say the speed of travel, but we want to smooth it out just like our movement. We don't want to skip, we don't want to skip, bendy lines, we don't want to skip, we want to gradually move to the second point. So in this, to do that, just like our movement script in episode 1, we just say we want to times it by time dot delta time, and we want to have a proper smoothing technique. We want to then, after we have this variable, we want to divide it by the distance that we're traveling. So for a long one, it'll take longer. For a short one, you'll travel a lot quicker. So to do this, we say get the vector3 dot distance between. So vector3 distance is just the distance between one point and another. So go back to our drawing here. So it's just this distance here. So one vector3 and another. So it's all it's just returning is another vector3. Get a proper range. We want to again put in our transform dot position and the hook point, because that is how far we'll be traveling in this variable. So once we did that, we can go ahead and test it really quick to see if it's working, and then we'll get some visuals up and running. Go ahead and add grappling hook. Here we want to say 15, and speed of travel, let's say we'll keep it at 9, and go ahead and hit apply and delete it from our scene. Post and aim it, and as you can see, we are working, but there's a lot of things we need to do before it is properly working. So to do this, we go ahead and want to get a couple things. So here we want to get a couple things. So here we want to get the character movement, make a reference to the character movement script that we have, and the rigid body that we have on our character. Because right now, when we grapple, our rigid body is constantly pulling us down, and we want to turn that off while we are grappling, so we have the desired effect. So to this, we say movement equals get component character movement. Because it's on the same object, all we have to say is get component, and it looks for all the components on the current script area, and it's just going through all these components and finding the character movement script. And just like the character movement script, we want to get the rigid body for that one, and we want to go ahead and open character movement script, and we want to make a public boolean and say can move. So we want to go say it's true from default, but oops, before we're going to be able to move, we want to say if can move is true, then we can move. If not, then it won't register these controls. So in our grappling hook script, we want to here when we're grappling, we want to say the movement dot can move is equal to false, and we want to say the RB, the rigid body dot use gravity, because the use gravity function is the one pulling us down, and we want to turn that off while we are grappling. So go ahead and save here and go back to our game and play it, and as you can see, it's a lot smoother, but we can't currently move because we are not saying we can move, and it's doing really weird things because we're not stopping the grappling. So to do this, go ahead and say A, we can either stop the grapple manually, so it's say if I didn't have parentheses here, and we'll go ahead and do it so it is needed. And so if input dot get mouse up this time, so we're shooting it when we're pressing it down, but when we let go, we want to say we want to stop it. So as the other ones, we want to send to the server that we're stopping the grappling hook, so it is able to call it on each client that we are currently stopping our grappling. So here we have another command, stop grapple. Command void copy and paste, and again just call an RPC function here. So RPC stop grapple. It's really repetitive, but you have to tell the clients that we are stopping the grappling hook. So now we just go ahead and create the function, and again client RPC copy void that's why. And for this, now we just say is grappling equals false, movement dot can move. So we're basically just reversing what we did in the RPC start grappling hook. So and here we say we can move again, and rigid body dot use gravity equals true. And now that we have a function here, we can go ahead and create a automatic one. So we have the manual stop, but now we can go ahead and make a manual one. So go to the RPC grappling function and go if the distance between our current transform vector3 dot distance between, so the distance between our current position and the hook point is less than, we'll give it a leeway of 0.8. You can change it however you feel like, but 0.8 is good enough for me. You can make it 0.5 is a good one as well, but 0.8 is probably the right amount. So here all we have to say is command stop grapple. So if we go ahead and test it right now, post and point up here, and there we go, it stops automatically, and we can stay back here and stop by clicking letting go of the right mouse button, and it will manually stop as well. So go up here, oops, and it stops automatically. I just want to show you here then. And now that you see it's working, now all we have to do is go back to here. Now we want a visual cue that we are, so just like a rope or whatever. So to do this, we have to get a line renderer, sorry, and call this LR. And here, make reference to it. LR equals get component. We're gonna add it right after and say it will be the line renderer. So here, when we start the hook, we want to enable it because it will start off disabled because we're not actually grappling from the start. So at the start, it'll be disabled, and we want to re-enable it. So here, we'll say enable equals true, and we want to set the line renderer, set position. So we want to set the first position. So 0 is the starting point and 1 is the end point. So the end point is going to be the hook point, and by default 0 will be the starting point, which will be our body. So actually no, down here in the client RPC we have to go ahead and say, we just have to be safe and just say the starting point will be our current transform dot position. So it will always be where we are currently. So disregard what I said before, it will start on 0, but now we want to have the correct transform, which will be our current transform position. So go back to our prefabs, go to here, and we want to add a line renderer. And by default, so let's drag it into the scene here, and we want to disable it, and we'll make the starting parameters 0.3 and 0.3, and let's just see how it works now. So let's apply, see how it looks now, and as you can see, we don't disable the line renderer. So to do that, we say when we stop the grapple, we want to go ahead and say the enabled state is false. So now everything should be perfect, and hope you guys enjoy. You can, before I leave you actually, you can make your own materials, rope material. So instead of the default pink color, you can go ahead and create your own material here, and you can make it whatever you want. So that finishes off our 2-week goal. I hope you guys enjoyed, and I am planning to bring out a lot more content in the next couple of days, so stay tuned. Thank you and good night.